Hello everyone, in this particular video we are going to see the problem on the clipper operation. So, draw the transfer characteristic for the clipper circuit shown. This is a clipper circuit they have given. So, by changing the input voltage, the output voltage will be changing, okay. And because here by seeing the circuit itself we can able to tell it is the clipper circuit, and we need to draw the transfer characteristics. Transfer characteristics means on x axis we have to take input voltage, and on y axis we have to take output voltage. So, like this we have to draw the graph. That means you need the relation between V0 and VI. So, the mathematical equation if you have in between V0 and Vi, then it is easy to draw the transfer characteristic curve, okay. So, that is what we have to do for this particular circuit. So, see carefully here, observe the circuit first. We have two diodes. So, when you know about the on state and off state conditions of the diode, then easily we can able to get the relationship between V0 and Vi. That means for what values of the input voltage, okay, or for what input voltages the diode D1 will get on state and diode D2 will get on state. That is what we need to have. Then if it is in the on state, we can replace the diode with short circuit by assuming the ideal diodes. Then we can able to get the relation between output and input. Similarly, you need to know for what values of the input diodes will be in the off state. Okay, this is what we are going to see. Now, if you observe the diode D2 N side is connected to ground through 30 kilo ohm resistor, and diode D2 P side is connected to 40 volts battery DC voltage through 10 kilo ohm resistor. For example, you did not apply any voltage, that means Vi is equal to 0. We can tell that diode D1 N side is connected to 40 volts again through 10K, but if you make this P side voltage 0, if you make the P side voltage of diode D1 is 0, that means Vi is equal to 0. What will happen? We will see once again, okay. So, if you make input voltage is equal to 0, that is P side of diode D1 is 0, okay. So, if Vi is equal to 0, P side voltage of diode D1 is 0, but N side voltage is positive voltage is there because of this 40 volts, N side voltage is positive voltage. That means surely we can tell Vp is less than Vn for diode D1. So, diode D1 will go to reverse bias open circuit. And in this particular situation, if you draw the remaining circuit, that is 10 kilo ohm, and here battery diode D2 is available, and 40 volts DC supply is there, and here one more resistor 30K is there. We need to take output across 30K. Easily we can able to tell diode D2 will go to forward bias now, because D2 N side is grounded through 30K and D2 P side is connected to 40 volts through 10K. So, positive voltage will be available at the P side and N side voltage is 0. So, that we can tell diode D2 will go to forward bias. So, we can replace with the short circuit. So, diode D2 is replaced by short circuit. Here 10 kilo ohm is there and 40 volts battery, and here we have 30K, and across 30K you have to take output voltage. Across 30K you have to take the output voltage. So, simple circuit, voltage dividing circuit, okay, 40 volts is divided between 10K and 30K, and resistor ratios also they have given easily 10K and 30K. So, 40 volts will be divided between these two. That means out of 40, 10 volts will be taken by 10 kilo ohm resistor and 30 volts will be taken by 30 kilo ohm resistor. So, we need output across 30K, that means output is 30 volts. So, simply we can tell this entire operation has been done when Vi is equal to 0 now, okay. When Vi is equal to 0, whatever we have done till now, we have observed that output is equal to 30 volts, okay. That means here 30 volts is there, already diode D2 is short circuited. So, this is same node, that means up to here 30 volts is there, okay. So, when you make Vi is 0, this is what is happening, output is equal to 30 volts we got, and if you take this node is A, so we can tell output voltage is 30 volts, or when input is equal to 30, we can tell VA is equal to 30. That means here one thing you can able to observe, VA is 30 means inside voltage for the diode D1 is 30. Okay. So, to make this particular diode is on, you have to apply the P side voltage is greater than 30. Okay, this is the critical part of this particular problem. So, listen carefully. We have made VA is 0, we got output is 30 and VA is also 30. But VA is inside of diode D1, this is D1, here you have 30. So, this is VA actually. So, until what voltage of the input diode D1 will be in the reverse bias. If you apply VA is less than 30 volts, so diode D1 is in reverse bias only. Not only for VA is equal to 0, you apply 1 volt, 2 volt, 3 volts up to 30 volts, diode D1 is under reverse bias only, because inside voltage is 30. So, P side voltage, that means input voltage, if you apply less than 30, diode D1 will be in reverse bias only. If it is in reverse bias, then whatever we got the output voltage, that is what is happening. Okay, that means output is 30. So, this is the relation we got, one relation we got, that is below 30 volts. Okay. So, once again I am writing here, when input voltage is less than 30, diode D1 is in reverse bias and diode D2 is getting the forward bias because of the DC supply 40 volts and output voltage is equal to 30. So, you observe input and output, when input is less than 30, output is equal to fixed at 30. But when you apply VA is greater than 30, VA is greater than 30, diode D1 will go to forward bias and diode D2 is also in forward bias. Both diodes will be short circuited. At that time, if you observe the circuit, D1 is short circuited, D2 is short circuited, whatever the resistors are there, that is okay, and output resistor is also 30K, but output exactly in parallel with input now. Okay, these two are parallel branches only. So, here you will get output is equal to input. Okay. So, now if you write all these relations at one place, when VA is less than 30, output is equal to 30. When VA is greater than 30, output is equal to input. This is what we got. Okay. So, here one thing you have to observe, problem is over, but some more time I will spend on this particular problem. So, see carefully, do not think that here 40 volts is available. So, inside voltage is 40. So, when input is less than 40, output is, sorry, when input is less than 40, diode D1 is under reverse bias. This is wrong approach. Okay. 40 volts is available here, from this node to this node 40 volts is there. But in order to comment on the status of diode D1, okay, in order to give the conclusion on the status of the diode D1, here 40 volts is not available. This voltage is VA, that is 30 volts only, that is 30 volts only. So, input voltage is to be compared with 30 volts to give the status of the diode D1, that is the critical part of this particular problem. Okay, from the problems also we can get the knowledge. So, you should not compare the input voltage with 40 volts in this particular problem, because out of 40 volts 10 volts is taken by this 10K. That means here you have at VA, you have, that means at node A you have the voltage 30 volts. That means inside voltage of diode D1 is 30 volts. So, input voltage is to be compared with 30 volts only. So, this is the exact transfer characteristic equation. So, this is called transfer characteristic equation, which is relating input and output. Now, with this we can draw transfer characteristic curve. So, we are comparing input with 30 volts, output also having 30 volts level. So, when input is less than 30, that means left side of this particular 30 volts notation, output is exactly 30. Okay, this is what we will get. But when input is greater than 30, output is equal to input, that means V naught is equal to VA. So, V naught is equal to VA, here V naught is equal to 30 volts. That is what we have to observe here. Okay. So, understand the problem very clearly, then easily you can able to do all these things. Thank you.